We're going to begin this review by looking at all of these problems, making sure that you have the right understanding. And then that way you can go back and fix your mistakes where they occurred. Remember, inverses, you switch x and y, so we write it as x equals negative 1/4 y minus 3, and then we solve for y. Beginning by adding 3 to both sides of the equation, x plus 3 equals negative 1/4. Remember to multiply fractions by the reciprocal. Do not forget about the negative. We must multiply by the negative. So it's negative 4x minus 12 equals y. Number 2, we're asking for the domain and range of the inverse from number 1. Well, the inverse is a linear function. The domain and range of a linear function is all real numbers. Number 3, finding the inverse of a model. Well, all that means is that you're going to switch x and y values within the table. So we're going to go negative 6, negative 14, 8, 12, and 17, and the range or the y values to negative 1, 0, 5, and 4. The domain and range for number 3 is not an interval. It is a list of numbers. Your domain in roster notation is negative 6, negative 14, 8, 12, and 17. Your range, again in roster notation, is 2, negative 1, 0, 5, and 4. Bracket each of them. Denote range as the y values. Denote your domain as the x values. In order to graph the function and its inverse, you have to find the inverse of this, so we'll go ahead and switch x and y. So we get x equals 1/2 y plus 5, subtract 5 to both sides, and you get x minus 5 equals 1/2 y. Multiply both sides by 2, and we get y equals 2x minus 10. So up here to 5, slope of 1/2, that's up 1 over 2. And we draw our line. Roughly there. Then we do the exact same thing. Negative 10 is down here. Up 2 over 1 puts it there. And again, we draw our line. The last thing you should denote here is your line of symmetry, and that line of symmetry is the reflection line y equals x. Warm up number 2. Parent function review. Make sure that you understand what your parent functions are. More importantly, make sure you got your critical values. Over 1 up 1, over 2 up 4. Remember your symmetry for that quadratic, and you've got your parabola. Y equals x squared. Absolute value, you have a slope of 1 on one of the arms. You have a slope of negative 1 on the other arm. Absolute value of x. Square root parent function, over 1 up 1, over 4 up 2, over 9 up 3, critical values. Y equals the square root of x. Number 4, the cubic, over 1 up 1, over 2 up 8. And with symmetry, this is the exact same. There. And like so. Cubic is y equals x to the third. Exponential parent function, one critical value there is at 1. Has an asymptote at horizontal line 0. and it is any base that you want. I'm going to pick 2 to the x power. Domain and range. What are the domain and range of the following function? We automatically know that a is out because the domain of a quadratic is always all real numbers. We automatically know that d is out because a quadratic function has a minimum or a maximum. Therefore, the range has limitations. We just have to determine what that limitation is, and you either graph it or you use the vertex, that's the opposite of b over 2a, to determine that your minimum in this case is -10, and C is your correct answer. Then we're going to go ahead and talk about the total surface area with a radius r centimeters. So we're looking at an object that has a radius. That means the radius has to be a positive number. That means that 0 is the least number we can use. While it's unrealistic to move to infinity, there is no cap on the size of this total surface area or the size of the cylinder. Therefore, the domain of this is greater than 0. Number 3, the graph of the square root function is shown here. That's below. The domain and range are the starting point. So the starting point is here at -4 is 0. So therefore, -4 is less than or equal to x, and the range is 0 less than or equal to y. What is the range for this function? Well, we go back to our transformations to see how that happened. We know that the vertex of this thing is at 2, 4, and it's a V shape in an upward direction because there is no reflection. Therefore, the bottom of this graph is at 4, so the range is 4 is less than or equal to y. Find the solution or solutions to the following equation. Make sure that you understand that absolute value always has 2 solutions, and you only begin finding those 2 solutions after you've isolated the absolute value symbol. 6 equals absolute value of x minus 2. Now we write our 2 equations. 6 equals x minus 2, and -6 equals x minus 2. That means I'm going to add 2 to both sides of this equation all the way across. And my answers are x equals 8 and x equals -4. All right, which of the following is the solution to this system of functions? I believe we have an error here because there is no solution here, but I'm going to go ahead and keep that consistent just to help you understand that there is no solution here. I believe that should have been a +1, and that would have made that your solution. So what you're looking for in the table are the places where the values are identical. Number 2, what is the y value to the solution matrix equation below? This is matrix A, this is matrix B, and remember, when you input them, you take the inverse of A and multiply it by B, and that means your answer is -6. The key to number 3 is that you are putting everything in order and that there is a structure to your matrix. So we'll begin by rewriting it so you can see what it looks like. There's your solution x, y, z equals, and we'll put our solution matrix over here. So that means there's a 0, there's a 3, and there's a -1. Remember, no variables go in the matrix. Recognize that. Test-taking strategies. 1, -2, and 0, and 2, 1, -3. And then we put our solutions over here. -3 and 6. There's matrix A, there's matrix B, and just like before, make it the inverse and you're good. All right, matrix here as well. You've got 3, 4. Let's make this sodas and hot dogs. 9, 25. 5, 7, and 16. Again, matrix A, matrix B. Take the inverse and multiply them together. You get $1.75. Sorry about not giving you the answer to number 3. That was -3, 0, and 4. Next and finally, your transformations. What are the transformations used to move this to that? Well, we have a number inside, that's left and right. Remember, it's the opposite of what you think, so that is my right 2. It is always the same as what you think on the outside, so that's your up 4. Okay. The name of the parent function is quadratic. And it is y equals x squared. Transformations have a reflection over the x-axis. You have a left movement of 1, and you are down 5. The graph of the cube root function, that's y equals the cubic root of x, is flipped over the x-axis. Y equals negative cube root of x. Remember, if it says y-axis, the negative goes inside. It is shifted to the left, so that will be the inside movement, opposite of what you think, plus 1. And up 5 on the outside, and the same as what you would think. Number 4, what I like to do is I like to graph the points in each table and see how they translate to each other. So negative 5, 9 is here. And in the second table, 0, 5 is here. That means from moving from this point down in line with this point is down 4 units. Moving from this point horizontally to that point is right 5 units. Now I'm looking to match down 4, right 5. That's not down 4, but these two are. So now I've got to decide which one it is. Well, the rightward movement is always opposite of what I think, therefore the answer is C.